in this video, we're going to solve limiting reactant problems. So in number 1, determine the limiting reactant using the balance equation. If an 80-gram solution of sodium hydroxide, which is 40% of sodium hydroxide by mass, reacts with 75% of solution of sulfuric acid, which contains 45% water by mass. So, first step, we need to balance the reaction from problem number 1. So, sodium hydroxide plus sulfuric acid reacts to sodium sulfate plus water. So, you write the balance equation. So, you write 2 here and then 2 here. So, it's perfectly balanced. And we have a given here. We have 80 grams of solution of NaOH. So, there's a pure grams of pure mass of NaOH is equals to 80 grams. And we have 40% of NaOH is equals to 40%. And we have 75 grams solution of sulfuric acid. So there's a pure mass of sulfuric acid is equals to 75 grams. And then the percent of sulfuric acid, which is 45% contains water. So it's a contains water here. So 100% minus 45%. So equals 100 minus 45 is equals to 55% of sulfuric acid. So let's begin. Solution. So mass of sodium hydroxide is equals to 80 grams. So 80 here. 80 grams times the percent. So 40, which means 0.40 times 0.40 is equals to 80 times 0.40 is equals to 32 grams of sodium hydroxide. And then we have a mass of sulfuric acid. We have 75 grams times 0.55. So 75 times 0.55 is equals to 41.25 grams of sulfuric acid. Okay? And then let's convert grams to moles. Okay? Moles of sodium hydroxide is equals to 32 grams of sodium hydroxide times the molecular weight of sodium hydroxide, which is 40.01 grams of sodium hydroxide. And we have a 1 mole of sodium hydroxide. And then cancel out grams here. And the left is moles. So 32 times divided by 40.01 is equals to 0.800 moles of NaOH. Okay, and then we have moles of sulfuric acid is equals to 41.25 grams. So 41.25 grams of sulfuric acid times, we have the molecular weight of sulfuric acid, which is 98.1. So it's 98.1 grams of sulfuric acid times 1 mole of sulfuric acid. So cancel out grams, and the left is moles. So 41 divided by 98.1 is equals to 0.417 moles of sulfuric acid. Okay? After that, which is the smaller number? So the smaller value here, which is sulfuric acid. So convert sulfuric acid to the moles of sodium hydroxide. So from moles of sodium hydroxide is equals to 0.417 moles of sulfuric acid. So 0.417 moles of sulfuric acid times the ratio. You can look at the reaction. We have a 1 mole of sulfuric acid here. So it's 1 mole. You put a 1 mole here, sulfuric acid, and then 2 moles of NaOH. So 2 moles of NaOH. So cancel out by its moles. So we have moles of NaOH is equals to 0.417 times 2 is equals to 0.834. So we have 0.834 moles of NaOH. So make sure the new moles of NaOH is greater than the old moles of NaOH. So 0.834 is greater than 0.000. So therefore, the limiting reactant is NaOH, and the exist reactant is sulfuric acid. So that is the final answer. Right? How about in problem number 2? So in problem number 2, if 40 grams of phosphoric acid react with 60 grams of magnesium carbonate, the grams of magnesium phosphate produced is the letter A. And the B, the grams of carbon dioxide produced. And letter C, the volume of carbon dioxide produced at STP. So let's begin how to solve that. So first step again, you need to write the balance equation here. So let's write the balance equation first. From phosphoric acid reacts to magnesium carbonate. So let's write a balance here, number 2. So phosphoric acid plus magnesium carbonate reacts to magnesium phosphate plus carbon dioxide plus water. So this is not a perfectly balanced yet. So you write a 2 coefficient here and 3 coefficient here. And we write a 3 coefficient here in magnesium carbonate. And we write a 3 coefficient here in carbon dioxide. So this is perfectly balanced. Okay, we have a 40 grams of phosphoric acid here. 40 grams of phosphoric acid and 60 grams of magnesium carbonate. So it's again, we have 40 grams of phosphoric acid and we have 60 grams of magnesium carbonate. So 60 grams of magnesium carbonate. And then let's find the limiting reactant first. So solution from 40 grams of phosphoric acid times the molecular weight of phosphoric acid, which is 98 grams of phosphoric acid, and then 1 mole of phosphoric acid. Okay, so cancel out there. So 40 divided by 98 grams of phosphoric acid. So let's write here so equals 40 divided by 98 is equals to 0.4081 moles of phosphoric acid. Okay, and then we have the moles of magnesium carbonate. We have a 60 grams here, so 60 grams of magnesium carbonate, and then times the molecular weight, which is 84.3 grams of magnesium carbonate, and then 1 mole of magnesium carbonate. So cancel out the grams, and then 60 divided by 84.3 is equals to 0.7117 moles of magnesium carbonate. Okay, so we have a moles now. And which is the smaller value? The smaller value is the phosphoric acid. Okay, so N of magnesium carbonate is equals to 0.4081. So 0.4081 moles of sulfuric acid times the ratio. We have a 2 moles of phosphoric acid here, So let's write at 2 moles of phosphoric acid times the 3 moles of magnesium carbonate. So write 3 moles of magnesium carbonate. So you need to cancel out the moles of phosphoric acid, and the left is the moles of magnesium carbonate. So equals 0.4081 times 3/2 is equals to 0.612 mole of magnesium carbonate. So let's compare the value of magnesium carbonate here. So from 0.612 moles is less than 0.7117. So 0.7117. So the limiting reactant is the phosphoric acid, because the old magnesium carbonate is greater than the new magnesium carbonate. So therefore the limiting reactant is the phosphoric acid, and the excess reactant is magnesium carbonate. Okay, and then phosphoric acid is the limiting reactant. So let's answer the grams of magnesium phosphate produced. So in letter A, we have the grams of magnesium phosphate produced. Okay. Okay, let's start. We used the value of phosphoric acid, so 0. From mass of magnesium phosphate here. So mass of magnesium phosphate is equals to 0.4081. So 0.4081 moles of phosphoric acid times the ratio in the reaction, which is 2 moles of phosphoric acid. So you write 2 moles here, and then 1 mole of magnesium phosphate. So we have 1 mole of magnesium phosphate. So times the molecular weight, which is 1 mole of magnesium phosphate, times the grams of magnesium phosphate, which is 263 grams of magnesium phosphate, and then cancel out moles, cancel out the moles too, and the left is grams. So equals 0.4081 times 1/2 times 263 is equals to 53.66 grams of magnesium phosphate. Okay, this is for letter A. And how about in letter B? So in letter B, we have, the question is the grams of carbon dioxide here. The grams of carbon dioxide produced. So, mass of carbon dioxide is equals to 0.4081 moles of phosphoric acid times the ratio. We have, in the reaction, we have 2 moles of phosphoric acid. So 2 moles of phosphoric acid. And then in carbon dioxide, we have 3 moles of carbon dioxide. So 3 moles of carbon dioxide times 1 mole of carbon dioxide, and then 44.01 grams of carbon dioxide. So equals 0.4081 times 3 halves times 44.01 is equals to 26.9 grams of carbon dioxide. And how about in letter C? So let's write letter C here. We have the volume of carbon dioxide produced at STP. So volume of carbon dioxide is equals to 0.4081 moles of phosphoric acid times the ratio, and you look at the reaction, which is 2 moles again, 2 moles of the reaction. So 2 moles of phosphoric acid, and then 3 moles of carbon dioxide again. We have a 3 moles of carbon dioxide, and then times the ratio, which is 1 mole of carbon dioxide, the ratio is Tp, which is 22.4 liters of carbon dioxide. So, let's cancel out phosphoric acid and the moles of carbon dioxide, and the left is liters. So we have a volume here. So the volume of carbon dioxide is 0.4081 times 3 halves times 22.4 liters is equals to 13.71 liters of carbon dioxide. So that is your final answer. So that's all. Please like and subscribe.